PCBs or printed circuit boards are permanent circuits unlike the circuits you will build on a breadboard. While breadboards allow you to change components and rebuild any circuit, PCBs are designed for a specific circuit. PCBs are firstly designed using a program, then are printed, and lastly the components are added and soldered on the board. This video will cover the design process of PCBs. The analog and digital electronics module uses Eagle 7.6 to design the boards. You will find this installed on all the computers in the lab. You can also download any version of Eagle on your computer. You will first have to download the components board from Blackboard. It is a .brd file containing all the components your circuit needs and will be provided to you. Once you have it, run Eagle. This window will pop up. Click on File, then Open, Board, and select the board you downloaded from Blackboard. This board contains components for a demodulator. The other components are power connections and input and output. The convention is that top right is positive power, middle is ground, and bottom is negative. At the other end, there are the input and output, both having a ground connection. To move a component, click Edit in the top right, then Move. Now you can click on any component and move it. Or click right on the component you'd like to edit and choose Move. You can choose to copy and paste components, delete them, and rotate. We will now keep the components for an inverting amplifier. It is important that you are familiar with the components you are working with. For instance, know the order of the 741 chip pins to be able to connect them accordingly. The semicircle points the top of the chip. Knowing that, we can start counting from the left. You have here pin 1, 2, 3, and so on. To connect components with each other, click on the Wire button here, or go to Draw and Wire. Choose the blue option, 16 bottom, which means bottom copper. You can choose a wire style from here. You can add a wire width. Choose 0.032 as any other is too thin for the connections. First thing you will want to do is to get ground all around the board, as both the input and output and other components need to be grounded. When wiring the board, click on the pad of the component you wish to connect to and drag to where the pad of the next component is and double-click. If you have finished wiring, click Escape. If you want to delete a wire, right-click and delete, or use Ctrl-Z. There are a few mistakes that can occur when wiring the component. Make sure you don't have two wires too close to each other, nor do you have wires crossing. That can cause a short. Make sure you only connect the pins you intend to. You can have components close to each other as long as they do not overlap and the connections are spaced enough. We have now built the op-amp. The final step is adding a ground plane. This will allow the board to have less interference by serving as a return path for current from different components on the board. Go to Draw and Polygon. Choose 16 bottom, the same width as before, and set the insulation value to 0.016 and the spacing value to 0.032. Now draw a rectangle all around the board just like so. When done, click right and rename it as ground. If you click this button, you will be able to see your ground plane. Now your PCB is complete. While working on your design, it is important to save your progress as you go in different versions. Then, if any problem occurs, you can go to the previous version.